All right, you guys, test is tomorrow. So I'm going to talk you through this in class review. And then, yeah, when I see you next, we will take a test. So make sure you're getting this. And if you have any questions, that you reach out to someone else in the room who knows how to do it, or come see me before class. All right, number 1 here. This is find the area of each figure, show your work. It is huge to show me which formula you're using. I highly recommend you just name the formula before you even start the problem, because you will have the formula sheet sitting in front of you as you take the test. So use those formulas. So this one, see if you can name it. Tell your neighbor. Number 1 is a, right, parallelogram. Formula for a parallelogram is A equals BH. So you need to figure out what is your base and what is your height. Your base is any side of the figure. Your height has to be perpendicular to the side you used as your base. So our perpendicular is here, which means 7.2 is going to work as our height. You can call this your base, or it's the same length as this one across from it. So that is a length of 10. So if I'm doing base times height, I'm doing 10 times 7.2. So that comes out to 72. And then your label will be meters squared. Number 2, this one is, name that figure. A triangle, correct. Take your time on that, because I think a lot of times, people look at it and they just misname it. And I know you know that's a triangle. You may treat it as 2 triangles, but you definitely don't need to. This thing looks a little off kilter here. So I would call this 1 triangle. It's going to be way easier, less work. So a triangle is area equals 1/2 times the base times the height. Or you can do 1/2 BC sine A for a triangle also, but we don't have the SAS set up here. So we're going to use the 1/2 base times height. Your base is any side of the triangle, and the only side of the triangle we have right now is this one. That is a length of 12. And then your height is whatever's perpendicular to that base. So this is going to be your height. If we know this piece is 5, and we know this is a 45, 45, 90, that means these 2 lengths are your legs, if you will, and they have to be the same in a 45, 45, 90. So if this piece is 5 and the whole thing is 12, you'll go 12 minus 5 to get 7 here, which means you also have 7 for your height, okay? Because the 2 sides of that triangle have to be the same. So we would do 1/2, a base of 12, and a height of 7. So 1/2 times 12 times 7. You can just let your calculator. That's Kenzie. You want to say hi? Say hi to my students.
Hi.
Okay, 1 sec. Okay, sorry. So 1/2 times 12 times 7. Again, you can just plug that into your calculator. You get 42. And then we're talking feet, and you square it because it's an area. Number 3, tell your neighbor, what is that figure? It is a trapezoid, right? 1 pair of parallel lines. That's what these are. In this setup, whenever you see a 30 or a 45 or a 60, you should be thinking, where is my 30, 60, 90 triangle? This 30, 60, 90, across from the 30, remember that's always your L. Across from the 60, which would be over here, is always your L rad 3. And then across from the 90 is always your 2L. So if this is our setup, first of all, a trapezoid formula is going to be 1/2 times H times B1 plus B2. So your height is going to be this side of the 30, 60, 90. The first thing we should figure out, though, is what is L, because that's L rad 3 over there, and we need to know what L is. So if 8 is the 2L side, then just divide by 2. That means L is 4. And if this is 4, then this height is 4 rad 3. So we would say 1/2 times the height, 4 rad 3, times base 1 plus base 2. Your bases are the two that are parallel. So 8 and 12, you want the whole thing. 8 plus 12 would be your setup. And then this is the one where you just plug in everything but the radical. So 1/2 times 4 times either parentheses 8 plus 12, or you can just plug that in as 20. So let's see, 1/2 of 4 is 2 times 20 is 40. And then you can attach your rad 3 to it to keep it in simplest radical form, and then label it centimeters squared for area. All right, number 4, this looks an awful lot like the one you did on your quiz. Notice this is not a diagonal. Yes, it sits on a slant, and most people think of diagonals as slanted, but the diagonals of your figure are here, the green, and here, the red. In a kite like this, these two lengths are the same. So that's going to be 15 and 15, but the other two pieces are not. Anyone remember how to find that? Tell your neighbor. It is Pythagorean theorem. So I'm going to call this X for now. Okay, if I want to find X, I have this triangle. I'm going to say 15 squared plus X squared equals 25 squared. And then we'll just subtract the 15 squared. Remember, you cannot subtract the numbers. You need to square them first and subtract. So just plug it into your calculator how you see it. 25 squared minus 15 squared, and you get 400. So if X squared equals 400, take the square root of both sides. X is going to be 20. Okay, so that's this piece. But we want the whole diagonal, and some of you did that wrong on the quiz. We want this, the 3, plus the 20. So that's your other diagonal. We forgot to define this. This is a kite. So I'm going to go 1/2 times diagonal 1 times diagonal 2 for my area on this one. So plug in what we know. 1/2 diagonal 1 is 23. Diagonal 2 is 30. This is not drawn to scale, sorry. So 1/2 times 23 times 30, and you get 345 centimeters squared. Okay. Look at number 5. Name that figure. That is a triangle, right? But we don't know a height, right? Typically, we would say this is our base and this is our height, but we don't know those things. You can use one of the other sides as your base, the 7 or the 15, but we don't have anything perpendicular to that either. But I warned you about this. This is the one people always forget. You have a side, the included angle, and a side, right? So it is an SAS triangle. So we're going to say area equals 1/2 BC sine A for our formula. B and C are interchangeable. I'm going to call 7B and 15C. And then A is the angle. So you would plug in 1/2 times 7 times 15 times the sine of 104. So 1/2 times 7 times 15 sine 104. To the nearest tenth, we would get 50.9 square meters. Okay. Okay, I'm going to give you a little bit of time right now to try this one with a neighbor or on your own. It is find the area of a regular hexagon. So let's say our hexagon looks something like this, with a radius of 16. Okay, so I'll give you a little bit of time, not a ton of time, but maybe a minute and a half or two to give that a go, or at least get it started on your own. So if you need to talk to a neighbor to get that started, go for it, but just listen for when I start talking again. All right, come back to me if you are still chatting about it with someone else. The first thing you do on these types of problems is you need to find the angle that is formed with your apothem and the radius, right? So we're going to draw this line in, and we're going to figure out what that angle is right here. So that's the whole 360 divided by the number of sides, but then cut that in half with the apothem, right? So that will be 30. So if you look at this triangle, this angle is 30, this angle is 60. Okay, now from here you have options. You can do it the trig way, where you set up SOHCAHTOA, or you can do it the special right triangle way, where you treat it like a 30, 60, 90. They will both work. So it's kind of up to you what you like to do better. I'm going to do the 30, 60, 90 way right now because I think it's quicker and simpler. But if you want to set it up the SOHCAHTOA way and do it that way, you go right ahead. So in this setup, in a 30, 60, 90, this is your 2L, this is your L, this is your LRAD 3. So if I know this is 16, cut that in half, and this piece down here will be 8, which means LRAD 3 is 8 rad 3. So this is a regular polygon, 1/2 AP. So we're going to go 1/2 times the apothem, which is 8 rad 3, times the perimeter. And the perimeter you have to find. So right now we know this is 8. If we double that, then this side is 16. So we're going to go 16 times the 6 sides that we have. And 16 times 6 is 96. So that's the perimeter of our figure. That's what's going to go here. Okay. Now, if you leave this in simplest radical form, you would do 1/2 times 8 times 96. 1/2 times 8 times 96 is 384. And then you would attach your rad 3. And it said it was in feet. So feet squared would be your area. Okay, that would go there. All right, moving right along. Number 7, it says find the perimeter and area ratios for the similar parallelograms below, your first figure to your second figure. So right now, you're just given 2 side lengths. Because they're parallelograms, this side would be 8 also. So 12 corresponds to 8 here. Okay, your job is to simplify that. So 12 over 8, those are both divisible by 4. So that's a 3:2 ratio. Okay, that is your scale factor when we're just talking about side lengths. Now, they asked for perimeter ratio and area ratio. So we are going to say the perimeter ratio is always the same as the scale factor. And then tell your neighbor what you do to find an area ratio. Yes, you square them. So 3 squared to 2 squared is 9 to 4, and that will be the area ratio. All right, number 8 says if the area of ABCD is 45 square feet, what is the area of URST using the similar figures? So they are similar, okay? That means they're proportional. So our scale factor is 6 to 2, or reduce that to 3 to 1, okay? That's the scale factor. We're talking area. So you need to turn that into an area ratio by squaring it. 3 squared over 1 squared is 9 to 1. Okay, that's your area ratio. They have given us the area, 45 square feet, of the bigger figure. So we need to set up a proportion. 9 over 1 equals that 45 would need to go across from the bigger one, right? So 45 here and x here. And then how do you solve a proportion? You cross multiply. So we're going to say 9x equals 45, and then we're going to divide by 9. So 45 divided by 9 is 5. So your area is 5 square feet. Okay. All right. Number 9. This gets into circles and arcs. So again, you will have these formulas sitting in front of you. It says find the circumference. So you look at the formula sheet and you see circumference equals pi times diameter. Your diameter in this picture is what? It's 12, right? Diameter is the whole length across. So we're saying pi times 12, or switch that around, 12 pi. And circumference is a length. So that's just feet, not feet squared. Okay. Area of the circle, area is pi r squared. And again, you will have that sitting in front of you. So pi r squared, you need to turn it into a radius. If your diameter is 12, then your radius is half that, or 6. So you go pi times 6 squared, which is 36 pi. And now it's an area, so feet squared. Okay. Number 11, the length of an arc. So arc dB is this arc right here. Okay, you do the measure of the arc. In this case, it would just be here. We'll write it as dB, sorry. Over 360 times pi times the diameter. So this is going to be the arc measure 150 over 360 times pi, and then your diameter is 12, right? The whole thing across, same as it was for the circumference. You plug in this. So don't plug in your pi. We're going to leave it in terms of pi. You plug in 150 divided by 360 times 12, and you get 5. So your length is 5, and then attach your pi. And we are dealing with feet still. Feet is a length, so it's just 5 pi feet. Whereas this one, area of the sector, okay, this is a new figure. We want the area of this sector, LMN. Area of the sector is the measure of the arc over 360, and again, you will have this formula too, times pi r squared. So if the measure of the arc is 135 divided by 360 times pi, your radius is the one that's given here. This is 9, that's a radius. So 9 squared, right? And then you'll plug this into your calculator. 135 divided by 360 times 9 squared. And you get this number. Typically, we don't love decimals when we're leaving it in terms of pi, but this was a terminating decimal, right? This is the whole number, so we're not rounding this. So you can just write it like that. If you want to turn it into a fraction, 243 pi over 8 would work. I'm not super concerned about that. You can just leave it as this decimal. All right. Then we get into these last few, finding the area of a segment, and then probability. Okay, area of a segment. Basically what you're doing to find the area of a segment is you take the sector, which would be all of this, right? This whole thing. And what you do is you subtract the triangle from it. Okay, so start with the formula for area of a sector. That's the measure of the arc, and our arc right now is 110 divided by 360 times pi times the radius, which is 8, squared. Okay, so this is the area of the sector, and we're going to subtract the area of the triangle. And there are plenty of ways to do these types of problems, you guys. The easiest way, if I had to make a recommendation, is to just treat it like an SAS triangle, because radii will always be the same. So that's 8. And the measure of the arc will be the measure of the angle. Okay. So you have side, angle, side, or B, C, and A in that setup. So treat it like that. on your formula sheet, it will say the area of an SAS triangle is 1/2 BC sine A. Okay, so what you're doing is you're finding the area of the sector, the purple, you're finding the area of the triangle, the green, and then you're subtracting them, or if you want to write it how you see it, make sure you put parentheses around it. Okay, so we would do 110 divided by 360 times 8 squared times pi. Just plug the pi in right then and there. Oops, I messed up. Try it again. 110 divided by 360 times 8 squared. And then you can just do times pi, or you can plug it in times pi right off the bat. I just am in the habit of not because of how we usually write these. So this is 61.436, we'll say. And we're going to subtract from that. Now plug in the other one. 1/2 times 8 times 8 times the sine of 110. And you get 30.070. So your answer is to subtract those things. 61.436 minus 30.070. You get, we'll say to the nearest 10th, because that's what they asked us to do. This would be 31.4. And it is an area still, and we were working in inches. So that's inches squared. Okay. Last thing, number 14, find the probability that a random dart hits the target and lands within the shaded area. So take a look at this picture, right? The area of the trapezoid is going to be 1/2 AP, right? Area of a regular polygon. I said trapezoid, sorry. Try that again. The area of the pentagon is what I meant. You're doing 1/2 AP. So we're going to say 1/2. Tell your neighbor what your apothem is. Yes, it is this 5. Okay, that's the apothem. And then the perimeter. Now, this is a regular polygon, so 7 and 7 and 7 all the way around, right? 7 times 5. So that's 35. Okay, so the area of the pentagon is 1/2 times 5 times 35, or 87.5. Okay, your other figure is a rectangle. And the area of the rectangle is going to be 9 by 4, or 36 square centimeters. So if I want to find the probability that I hit the shaded, here's what we set up. Actually, tell your neighbor. How are you going to set that up? Remember, it's favorable over possible. In that, the probability of the shaded should have been pentagon minus rectangle, okay? That's your favorable, right? The shaded thing, whatever you're trying to find is your favorable. You put that over the total possible, which is your pentagon, okay? So let's plug that in. If we set that up, that is 87.5 minus 36 divided by 87.5. And just make sure when you plug that into your calculator, it's 87.5 minus 36, then hit enter. Okay, we want to calculate that difference first, and then we can divide. Divided by 87.5, and you get this number, 0.58857, okay? We're turning that into a percent, so multiply by 100, and that would be about 58.9%. What did it ask for? Round to the nearest percent. So that's actually 59%. So it is a 59% chance that if you throw a dart and it's gonna hit the pentagon, that it would hit in the grayed out area. Okay. All right. That is the whole review worksheet. You have the rest of class now to work on the homework, the book work. So go ahead and get started on that and have a lovely rest of your day, and I will see you tomorrow.